All right, so we're going to do some examples of composite area. Composite area is when you have a figure that is actually a combination of other types of polygons. So you have multiple polygons in the same figure. So that would be, for example, if you stuck a square and a rectangle together, or a triangle and a trapezoid together. So what we're going to look at here is we're going to look at number 6. And number 6 says find the area of the shaded region in the drawing of the squares at the right. So it tells you that they're squares. That's important because that information indicates that we have 4 right angles, and it indicates that all 4 sides are congruent. And it says that both are squares. So what we're going to do is round to the nearest tenth with our area. So to find the area of the shaded region, basically I need to find the entire area, the total area of the entire figure, and then imagine that the non-shaded region is a cutout. First thing we do is establish units. It doesn't ask us to show the answer in any particular units, so we're going to use the ones that we have. So we have millimeters and millimeters, which means we're not going to have to do any conversions. It's very important that you pay attention to the units because sometimes you'll be given units for the dimensions and asked to find the area or the perimeter in a different type of unit, and you have to be able to make those conversions. So let's find the area of the square first. This is a square, so since this dimension is 15, this one would be 15 millimeters as well. So the area of a square is side squared, or base times height, or length times width. There's 3 different ways you can write it, whatever's your cup of tea. So we'll find the area of the big square first, and the area of the big square, right here in purple, is 15 times 15. So that's going to be 225 square millimeters. Now that's the area of the big square. If I were to encompass the entire square and fill it in, that's the area. Now let's look at the area of the interior square, the small guy. So this little guy right here is 5 millimeters by 5 millimeters. So we're going to find the area of the small square, which is 5 by 5, which is 25 square millimeters. So I know the area of the entire figure, and I know the area of the region that's cut out. So all I need to do is subtract to find the area that is shaded. I want this area right here. So I'm going to take the 225, which is the entire figure, and subtract the 25 that's cut out. And so my area is 200 square millimeters. So that's one way we can use composites. Remember, composite means you're combining it. It's a composition. A composite means that you got more than one type. So now let's look at the next one. The front of the garage needs to be painted. Okay? So we want to paint the front of the garage. The total area, except for the door, will be painted. The door is 1.5 meters high and 2 meters wide. How many square meters of paint will be needed? Okay, so we're looking at the door. We're going to paint the entire front of the garage. So we're going to paint all of this area here is going to be painted, but we're not going to paint the door. It says except for the door. Okay, so what we're going to do is we're going to have to figure out how to find the area of the entire figure. The area of the door will be simple because it's rectangular, okay? So how many square meters of paint are we going to need? Well, let's divide this up. I'm going to divide this garage door into a rectangle and a triangle. You see the triangle there? In the front of the garage, you got a triangle and you've got a rectangle. So let's find the area of the entire front. Don't worry about the door. Just find the area of everything. This is a 2.5 meter by 3.5 meter. Again, check your units. Everything's in meters, and that's what it's asking. How many square meters? So we don't have to do any conversions. So I'm going to do 2.5 times 3.5 meters. That's going to give me the area of the front part of the garage that's rectangular, including the door. So 2.5 times 3.5 will be 6.25. So 6.25 square meters is the area of the entire front. That includes the door. Okay? Now let's find the area of the top of the garage. Well, this is a triangle. What's the formula for the area of a triangle? Well, the area of a triangle Whoops, let's do this in a different color because I can't make up my mind. The area of a triangle is base times height divided by 2. Well, what's my base of my triangle? Well, it's the same as this. It's 3.5 meters. So it's 3.5 meters for my base. How tall is my triangle? My height? 1.2 meters. Okay, so we have 3.5 times 1.2, which I'm going to get my calculator out because I do not want to think. And once you multiply those two together, if I can find this here, one moment please. If I can find my calculator here, I don't want to think. 3.5 times 1.2 hold on just a second, is 4.2. Okay, so we've got 4.2. So 4.2 meters squared is the area we'll have to paint for the top. So this is the area we will for sure have to paint, and then we're going to paint the blue, except we don't want to paint the white. So what I'm going to do is I'm going to subtract the area of this off of the total. And it tells you the door is 1.5 meters high and 2 meters wide. So the area of the door is 1.5 times 2, which is 3 square meters. So I'm going to paint this region here, which is the whole rectangle, 6.25. I'll write it down here. 6.25 minus 3, so 3.25 square meters. So I need to paint this, and I need to paint the purple. So together, I have plus 4.2. So I'm going to need 7.45 square meters of paint. So how many square meters of paint will be needed? 7.45 square meters. If a can of paint covers 2.5 square meters, how many paint cans will we need? Well, if we're needing to paint 7.45 square meters and each one covers 2.5, then we're going to take 7.45 and divide it by 2.5, which is going to be about 2.98 cans. Now, can we have 0.98 of a can? No, so that means that we actually need 3 cans. You can't walk into Lowe's and say, can I have 0.98 cans of paint? You have to get into a full can. So again, we found the area of the triangular region, we found the area of the rectangular region, the whole thing, subtracted out the door, and then we combined the triangle and what was left of the rectangle when we did the subtraction, and we got 7.45, which is how much paint we're going to need. And then each can covers 2.5, so we divided by 2.5. If a can of paint costs $24.50, how much will it cost to paint the garage? Well, remember, you need 3 cans. So we're going to need 3 cans at $24.50 a piece. So we'll have $24.50 times 3 cans, and that's going to be $73.50 that it's going to cost to paint the garage. And that's how you can do an application of the composite figures.